Thank you for joining the second season of Sertl Optics 360 Pulse. I am your host, Jennifer Sertl, Director of Marketing at Sertl Optics. 360 imaging is part of everyday life. Sertl Optics technology is being designed to accelerate the delivery of life-saving resources, ensure aerospace safety, and also increase the immersive participation experience. This podcast, 360 Pulse, is dedicated to featuring immersive technology and the innovators working on these capabilities. And today in the studio here at RockVox Studio in Rochester, New York, I have Dr. Emmett Ientilucci. He is the Associate Professor and Graduate Admissions Chair in the Chester F. Carlson Center for Imaging Science. Emmett has degrees in optics and imaging science. Prior to his faculty position, he was a research faculty postdoctoral research fellow for the intelligence community. He is the recipient of the 2020-21 Richard and Virginia Eisenhart Provost Award for Excellence in Teaching at Rochester Institute of Technology. And his research is quite fascinating. It includes spectral imaging analysis and variability, hyperspectral imaging processing, target and shadow detection, radiomic calibration, atmospheric compensation, and algorithm development, which I'm sure he's going to talk a little bit about algorithms and AI, of course. He has 88 publications, as well as a referee on 18 journals, including being an AE of optical engineering and current AE geoscience remote sensing letters. He's been a program reviewer for NASA, the Department of Defense, and is the chair for SPIE Imaging Spectrometry Conference and the Western New York Geoscience and Remote Sensing Society and the UAS Stratus Conference here in Rochester. He's a member of both IEEE and SPIE societies. And as if that was not enough, he's currently working on his spare time on a textbook entitled Radiometry and Radiation Propagation with Oxford University Press. You look so young to have like all of these accomplishments. What has inspired you to pursue a career in optics, and how did you get started in the field?
Yeah, that's a great question. And thanks for the lengthy introduction. But so after high school, I wasn't really sure what I was going to do. Actually, I started as an electrical engineering major at community school. And then after that, so I did a year of that, and I was working 2 jobs during the day. So that was actually at night. And then across from the hall, there was the MCC optics program, right? So I was at MCC at the time here in Rochester. And that looked really interesting, with the light and the pictures. So I checked it out one day and started talking to a couple of the faculty members over there. And I decided, you know what? I asked the guy, Bob Novak, can I switch majors? And he's like, absolutely. And so that was it. And I started full-time, quit both of my jobs, and was matriculated day student, graduated from the program. Did very well. And then after that, some of my colleagues, some went to U of R, and then some went to down south. One even, I think, went to U of A. That's the other big optics school. And I actually went to music school, completely left turn, and moved to Los Angeles. And there was a music school out in LA. And so I did that. I wasn't sure which direction, and I just knew that it's just one shot in life, and I wanted to try this. And the worst thing, if it didn't pan out, then I changed. It was young enough to, they say you have time when you're young, you could change directions and, not lose anything in your life. You still have plenty of time. So with that, that's exactly what I did. And it was great. And I lived there, and I was trying to work full time, graduated from school, and be a full-time musician. I just wanted to be a studio recording guy, right? I wasn't interested in touring, wasn't interested in playing in bands. I just wanted to be in the studio recording sessions all day. That's what I really wanted to do. But of course, the top 20 drummers in the planet, 10 of them live in LA. So it was very difficult to do anything with that kind of competition. It's all about who you know. Long story short, I ended up moving back to Rochester, and I started teaching music here, private lessons, full time, and then had some random job in shipping and receiving, that kind of thing. But I still had graduated and had my degree in optics at the time. Then I landed a job at Xerox Corporation in the research department, and I interviewed with an individual who would later go on to win the President's Award for Xerox, this gentleman by the name of Dr. Dan Hayes, and he was a drummer. And so I don't know if I mentioned drums. I guess I don't know if I said that already. But so Dan looked at my CV and he's looking through everything. He's like, oh, yeah, this, that, and the other thing. So it says down here under your extracurricular activities section, everybody puts that in their resume, right? It says you play drums. So what's that all about? And I was like, oh, here we go. So then I started talking about the drums. The rest of the interview was about drums. So, you know, and then he moved me into with a colleague of his into one of the labs, and you know, he gave me some circuit boards and other things, and he's like, okay, take this all apart and then put it all back together, and you know, all these things was pretty trivial for me. I used to work on cars as well. I was like, you know, doing repair on automobiles, and so I got the job. I worked there for 4 years, and I realized that I really like this, and I was still doing my music thing too, but I really, you know, revert back to what my other passion. So I have two big passions in life, which is science, STEM stuff, and music.
That's exciting.
And they encouraged me to go back to school. So I went back to school, and I worked there 2 days a week. It was either I worked there 2 days a week and went to school 3, or vice versa. Yeah, I forget. And so I did that, and I finished undergraduate degree, and then they asked me if I would be interested in being a member full-time research staff at Xerox Corporation, the Webster Research Center, which is, I think there's only, I hate to say it, but it's either maybe 5 research centers at Xerox. I'm not 100% sure, but Webster Research was one of them. And I talked to my colleagues at the university, and they said, no, why don't, because I applied for graduate school and I got a scholarship, and that was fully funded. And they said, you should just keep going with school and just finish that out. You could write your own ticket when you're done. Don't take the job now. And that was great advice. And, you know, and even today, that was great advice when I look back. So I did that, finished graduate school. Then I applied to the PhD program, and I got a scholarship for that, fully funded. So my graduate school never cost me any money, right? And I finished that. Then I interviewed with a bunch of companies all over the country, and I almost took a job in San Diego. And long story short, I got the research faculty position at RIT, which transitioned into a tenure spot, and that was a long time ago, and here I am. So it was quite a crazy path.
That's so exciting. There's two things that I think in terms of our listeners, many of our listeners are young adults. And the shout out to Monroe Community College. And in fact, across the country, all of the community colleges often have 2-and-2 programs where you do 2 years at the community college and then transfer over to a school in your local community. And any parents, I hear most of the issues is with the parents, not the students in that type of a track. And I just want to share that there are so many examples of great people with tremendous contributions in science that started out in that kind of track, which I think is really beautiful. The second thing is that we often find that in innovation, there is a link between science and musicians. And it seems as if that background is so important. And I know that at RIT, the president, Munson, has done a lot to increase humanities and the music programs, knowing that that's important to innovation. So I'm thankful that you actually are a wonderful example of that. Before we get into elements of the program, I really would love you to break down imaging science. It's such a vast field. Break it down for us.
Yeah, absolutely. So this is a question I get a lot. In terms of, so what do you do during the day, or what's your day job? And then immediately, you know, thoughts go through my mind. It's like, oh, here we go. How am I going to distill this? And because it's quite easy to say, oh, I'm an electrical engineer. I'm computer science. I program, right? Everybody knows what that is. I work in imaging science. What is that, right? And sometimes I'm trying to be funny and I say, well, it's the science of imaging, of course, right?
Very helpful.
Right. It doesn't help. Exactly. So, you know, I tell my students, so I teach undergraduate and graduate courses, and I always say, you know, when the photon leaves the sun or a light source or something that, for example, generates photons, and then ultimately hits your eyeball and you sense it, or maybe your camera, your cell phone or something like that, what happened? And that's what we study. So it's the light propagation. It's how it interacts with material. It's how you perceive the world once the light hits your eye. Why do things look like they do in terms of their color? How do you perceive things? Let's take the human out of the picture. What about the camera, your cell phone, right? So the photons enter this. You got these cameras. You got 3 different cameras on the new cell phones. What's going on there? You got the optics. You got a little detector in there that senses it, does some magic. We don't need to get into the details, but then you perceive it. It creates a picture and an image. Then you perceive the image. What about the color balancing in the picture? What about if you send a picture to a computer and ask the computer to determine what's in it? That's kind of where we are now with machine learning and AI and detecting, find the zebras in the picture automatically and count the number of cars automatically. We sort of take the human out of the loop now. So that's all the post-processing. So imaging science is indeed the science of the imaging, right? So it's a lot of physics, math, and programming. To recap, it's about, how we understand and perceive the world around us in images and the science behind all of that, right? So I don't know if that clears it up a little bit. But
I'd love, as the most succinct definition I've heard and very, very helpful. There's kind of a 2-part question. One is, what are some of the biggest challenges facing imaging science today as you see it? And then can you share some of the most exciting projects that you've been a part of that you can talk about? Because I do know you do quite a bit of stealth work.
Yeah, absolutely. So today, I think in my story I just painted a second ago about the photon and the cameras and all that stuff. We're pretty good at understanding that process. And, when light hits the table in front of me here today and interacts with this wood surface and, I see the it's kind of shiny and smooth and it's got a particular color and all that. We kind of understand, how the photon interacts with materials. We're pretty good at that. And then even going to the camera part, we're pretty good with that too. And our cameras now have our cell phones have multiple cameras on them now, because it's quite easy to break down the lens design, not with having one camera and many parts and trying to have the camera do wide angle and zooming and all that stuff, and get a great design with that. It's actually more effective to have 3 cameras. Each one kind of serves its own purpose and miniaturize those. We're pretty good at that now. I think the challenges are on the back end, where we currently are with AI and machine learning and computer vision. That's kind of the hot topic. Many of ours, and I know this to be fact because I'm the graduate admissions chair, and majority of the applications that come in, all the students want to do computer vision. They all want to do machine learning. And that's what every project I work on, we try to crowbar machine learning and computer vision into the project. My 2 students currently are working with me. There's a big component of machine learning in that right now, and trying to get that hammer to work, that tool to work in all these areas. Now, it's the big buzzword, right? This is machine learning, computer vision, and deep learning. Those are the big words now. But, it doesn't work for everything, but we're trying hard to get it to, it has great successes in many areas. But we're trying to get successes in some of my research projects. Some so-so, we haven't really made any huge breakthroughs, but I think the challenge is in that post-processing arena right now, how to get these new modern tools that everybody's familiar with to work across the imaging fields, all the imaging fields. That's what people are trying to do now. Part 2 is so how maybe I kind of segued into what I'm working on. So I've got some pretty cool projects. Every few years it changes a little bit because imaging science is so vast and broad, right? There's the science of imaging related to the really small, nanoimaging. There's imaging related to medicine and medical imaging, right? There's imaging from space looking down at the planet. That's remote sensing. That's the area I'm in. If you turn the telescope around in the other direction and you look out, there's imaging out into space, right? So that's astronomical imaging. And of course, there's optical imaging, right? Even related to fabrication, design of systems, and so on and so forth in the optics arena. So under the umbrella of imaging in our department, we encompass all of this. We have faculty with expertise in all these areas. So it's pretty multidisciplinary. It's pretty awesome like that. So my research in remote sensing can be multidisciplinary too. And specifically, I've got a pretty cool project I've been working on for 3 years, which is really out of the box, but pretty awesome. And it deals with me working with an explosives manufacturer. So there's a company called Austin Powder, for example. This is
it's hard not to think about Austin Powers. I wonder what a great marketing strategy they
they've been around 186 years.
Okay.
So they're pretty old company. But anyway, they've been fantastic. And the short and long of it is, so you go to a big quarry, and they're going to blow up a side of a mountain and fragment some rock, right? So they drill holes. They put ammonium nitrate fuel oil into these holes, maybe 60 feet deep, 18, 20 inches wide. Maybe it takes them a week or two to drill tons of holes. Then they fill the holes with explosive. And Austin Powder is the explosive manufacturer. They make the explosive. And then it gets detonated. I forget how many tons. And boom, you're a mile away when this thing blows up. It's an enormous explosion. The problem is sometimes there is a sort of an incomplete detonation where there's a nitrous oxide that gets released, and it shows up as like an orange gas. Now, this doesn't always happen, but that is poisonous. But these are really large fields, and maybe there's a large plume. Let's say it did happen, and it could waft over a small area, a small town or something. That's a problem if it happens. So regulatory agencies like OSHA comes into play and says, from now on, you need to report this and you need to tell us information about it. And you need to say, document things like maybe the volume of the cloud, or what is the parts per million? What's the ppm of the gas? We need information about, and they want to log this. And then if they could track this all the way down to which hole it came from, and then they could look at what was in the hole at the time. All the holes are GPSed. They blow up the GPS every single time they do a detonation, which is another thing. But so they have no clue how to do this, right? These are miners. They don't care about imaging. So through a weird series of events, which I won't explain because that's another 5 minutes, I hook up with this guy who's their VP of emulsions. And so he's like, can you help us? Absolutely. So fast forward, we have made sensors, NOx sensors, that we can put onto drones. And we fly, we've done this already, and we fly the drones through the gas cloud, and it samples the gas, and their GPS, they log GPS, they log ppm and parts per million concentration. And so we take that information and we can put it into a GIS platform to visualize spatially where the gas is, and specifically, think of an image and then having lots of dots across the image to show the flight path of the drone. And then each color on the dot represents the concentration. So, if it was red, that might be a high concentration. And then we have an environment for them where they can click on the dot and it would say, oh, this is 10 ppm. And then the blue dot, where there's no gas, maybe it's 0 ppm or something like that. So this is a huge tool for them. And then we have also, with a second drone, we can image the cloud and the plume, and we can get some estimate of the size of the cloud in terms of a volume. So that's pretty awesome. And then the third component, so there's many people working on this. Myself, I have a PhD student who's doing this, and we have 2 staff people that are also on the program as well. So, and the last other cool piece is, I don't know, they may probably 10, 20 detonations per day global. They have 250 sites all over the planet. They're headquartered in Cleveland, so I visit their office quite a bit. But all the videos come in and they go to a central server. So there's an explosion, detonation at a strip mine, and there's a pilot with the drone, and he's taking the pictures. He pulls the data off of the drone, and then it all gets sent to like a central place from all over the planet. And maybe they get 20 videos a day. No one's going to sit there and look at 20 videos a day to see what's going on. That's not happening. What they need is an automated process, a black box algorithm, if you will, where the video comes in, goes into the black box, and then the black box spits out, hey, there's NOx gas in this video. Flag it, right? And then maybe that goes into a database. And this happens this way. Maybe in a month from now, somebody can query a database and say, hey, you know what? I want all the locations or the videos that have NOx in them for the month of March. And then they hit some buttons and boom, they're all. Then they can analyze the videos. They currently have an algorithm that sort of does that, but there's a lot of false alarms, not so good. Long story short, we made a new algorithm and it works great. And it can sense in the video imagery if there is NOx gas in any of the frames and then, create a flag. And we're right now in the process of transitioning the code to them. So we are now working, I have meetings every week with their IT department, and we're transitioning the algorithms to there so they can put that into their pipeline. So in summary, company, explosives manufacturer, sometimes they have an NOx gas cloud, not good. They need to record information about that. Our IT, imaging science, remote sensing department sort of comes to the rescue, came up with some techniques and algorithms with drones and sensors and machine learning to detect whether there is NOx gas and how much. And now some of that code is being transitioned to their pipeline.
What's so great about that story, and I really appreciate it, is the idea of how important imaging science is for the Sustainable Development Goals and our ability to use the science for real world problems. Not
Absolutely.
just, I think sometimes people think of it as sexy and kind of fun and that, but like this is serious science that is actually going to solve problems that are emerging problems and problems that we existing have in a way that can actually create information at scale that can create positive change. Am I correct in that?
100%. Yeah, that's absolutely right. And the cool thing about this particular problem, it encompasses so much of imaging science, from the hardware to, now NOx gas, and that's all chemistry. And I don't know too much about that other than the chem courses I've taken 1,000 years ago.
Right.
But there's the drones, and we're big on drones now. Yeah. And then like I said before, my student is working not on the hardware stuff, but we give him the videos, right, that we've captured. And then his part is to pick up the story from there and then process the data, the videos, and the algorithms with the machine learning. And that's what we're doing. So it's a big chain of stuff, right? It is. So it's all encompassing. My last comment is you need to have skills in physics and math. For this particular project, there's some hardware. We designed some circuit boards and stuff. So Bob Kremens, our research staff guy, is doing all that. And then you need to have the machine learning and the computer vision and be able to program in Python and stuff. So it's a lot of stuff, right? So it's very, like I mentioned before, the interdisciplinary idea comes to play.
Well, so what's so exciting, and our team at Circle Optics has been gone to Chester Carlson Center for Imaging Science and seen and look forward to future collaborations. And the point that I really appreciate you making, Emmett, is the hardware connection to all of this. It seems in the world you hear a lot about software. I almost feel like it's the Graduate, right? It was all about plastics. And now I think one of the reasons we started 360 Pulse podcast was the idea that hardware and deep tech is integral to allowing all these things to work. And so your example there was a really great kind of wanting to weave in Circle Optics as a hardware, we're solving a problem. Right. That is a hardware solution, which is great. You are so passionate about what you do. It's so clear on your really, you explain really complex things in a very succinct way, which is well. What is the most rewarding experience for your career so far, and what kind of keeps you in the question?
Yeah, absolutely. So, I got into this, and this is, I tell my students the difference between a career and a job, right? So a job, maybe you could think of it, maybe not so much, but punch the clock and that kind of, and you can't wait to get out of there at 5 o'clock, get me out of here and that kind of. A career is not that, right? It's something you're passionate about, and if you're lucky enough, you find that, right? So for me, my example is trade magazines. I get a lot of trade magazines. I get the optics. I forget what it's called. So many that I can't remember the names, right? But there's some from the different societies. I get from SPIE, OSA, or Optica now, and IEEE Spectrum. And I look at those and read those all the time. So what I mean by that is Tuesday, Saturday, it's all the same. It's not. When I get up, it's like, 8 to 5. I don't think like that, right? Yeah. So because it's just part of my life. It's what I would do if maybe I didn't have this quote job, right? So the idea of one day getting an email from our program managers that said something about, hey, there's an interesting call from NASA. Well, there's actually, I just thought of this, but there is an interesting call that just showed up not too long ago. There is a new spectral sensor on the International Space Station called Emmett. And there's a call.
Sure it's not called Emmett?
I know. So that alone, I have to write a proposal for it, right? I mean,
I apologize, but it's just too good.
I completely agree. So, there's a call for proposals for that to do some really cool work. With that sensor. They've collected 20,000 radiance cubes, and now they're asking the community in the world basically, okay, write some proposals and do something with this.
Yeah. So
we're gonna, one of my colleagues and I were gonna write a proposal to do some cool stuff with the Emmett sensor on the space station. So I did 4 weeks ago, I had no idea that even existed. I knew about the sensor, but not the call for the proposals. And so who knows? In another year, I could be working that program. I could be down at JPL hanging. So it's different. I don't know what I'm going to be working on in 2 years, roughly, right? The Austin Powder thing came out of left field a couple years ago, and now here we are 3 years later, and he's going to renew, our sponsor is going to renew for another year. And we're doing cool things with drones and strip mining and blowing up stuff, and I get to go to their test site and, we blow things up. I mean, it's unbelievable, right? And so who knows what, and the drone thing too, and this, I've got this drone conference. So I don't really know what's going to happen in a few years. I mean, it's all going to be imaging and optics and designing cool things and solving cool new problems, and it's unique, but it's not the same thing every day. Every day is completely different, right? We're doing cool stuff in the lab with my student now that just started like a few months ago related to the Austin program. I work with Oak Ridge National Lab. I did work for them for like 6-7 years. I thought that was going to be a one-year contract. I had a phone call. I was in a meeting for a Landsat. I was just another satellite. I was in Arizona, and I get a call about, writing a proposal to work with Oak Ridge. Fast forward, I had a 7-year contract with them doing all kinds of cool stuff. Who knows? So, what keeps me engaged is that. Every day something new is going to happen. It's not like, I'm working on designing widgets at a table every day from 8 to 5, and it's the same widget over and over and over. And, it's not that. It's complete opposite.
So there's a wonderful book called The Arc of Ambition, and it identifies architects, builders, maintainers, and optimizers. And I think all four are essential, but clearly you're an architect. And like to work with that open space. I know it's like this conversation is so exciting. I know I have more questions, but I can keep it down to 2.
Of course.
One thing I did want to mention, Optica, a publication that he had recommended, there's Optics and Photonics News, and our founder and CEO, Zach Niazi, is one of 10 entrepreneurs featured in their July-August issue. And so it's biannual, and I'm so hopeful that you all check that out. And I hope you'll check that out as well. The next 2 questions. You did mention the conference that you have, Stratus. It's an event that your team puts together annually, and Circle Optics has attended 2 years in a row. And it's a really great conference. Can you just share a little bit about the intent this year and a call for papers so that we can begin to circulate that for you?
That's great. Yeah, thanks for the opportunity to plug that. So Stratus. It's a UAV conference. It started out as a one-day workshop. Actually, I wrote a short little proposal for, I think, $2,000 or $4,000 to the Geoscience Remote Sensing Society. So that's an IEEE society. So the call was about, hey, you want to put some colleagues together and have a little workshop on a topic of your choice? And so another colleague of mine, John Karekis, we chatted about this. He's like, yeah, let's do something about drones. We started our new drone program in the remote sensing department, and, we're totally tooled up, and that's really taking off like gangbusters. And we should get some people and make it regional in Western New York or, Buffalo, Rochester, Syracuse, and see if we can get some folks to get together. So we had a one-day little workshop with the $4,000, paid for some of the food, and there's a lot of logistics involved in these things, but it all worked out great. Everybody loved it. Fast forward, I think we just finished our 6th conference. Now we changed the name to a conference, and it's 3 days. And this last iteration that we just had, it was at RIT. I like to rotate it around. So one year it was at University of Buffalo. 1 year it was at Environmental Science and Forestry at Syracuse, ESF, SUNY ESF in Syracuse. Majority of the time it's been at RIT. This last iteration, which was just this past May, it was at RIT. We had maybe 90. The attendance was a little bit lower. I like trying to get up to like 150 people, something like that. But then other logistics come into play about, well, do you have a room big enough to accommodate that, and so on and so forth. But we had about 90. And the cool thing was we had people from Norway, Germany, and I think 12 different states. So it was more reaching than what we have had in the past. The definition of this was sort of, let's keep it regional, Western New York, And there are plenty of UAV, UAS conferences in the country and in the planet. There's the UAV Expo, of course, but this is completely different than that. This is about everybody over there. They're selling their drones and who's the latest drone. This conference is not about that. This conference is about, not about, hey, I've got a new rotor design, a new motor. Let's give a 10-minute talk on that. No, this is about, we've got the drone. What did you do with it? You got and remote sensing. You're flying over bodies of water. You're detecting harmful algal blooms. People can't swim when you see those out there, right? And can you take the images and you process the imagery? What are the results? What'd you find out? Give a talk on that. Or if you're doing synthetic aperture radar on a drone and this is sort of a new field actually. And those drones are quite pricey. What do you do with the data for that? So on and so forth. So our conference is really about gathering folks together that use data, application-driven with the drones, tied to remote sensing, maybe emergency response. That's another big hot area with drones. And we get a variety of usages, application areas that people have used the drones for and then come to present to us. And the other piece that I really try to tell the folks at the meeting is network. The reason why you're here is not just to give your talk and leave. You need to give the talk and you need to talk to other people. That's the other half of it, right? Not just watching the talks and then go home, right? Or go back to your hotel. You really got to network with other people because again, how do you know that in 1 or 2 more years, you might form a company with this person, or you might be on a proposal together, or you just don't know. So I always encourage, I have like a lunch networking thing where I make everybody stand up for 10 seconds or 30 seconds to say who they are and why they're here and keep it to 30 seconds. And then after that, we're eating lunch. And then after that, I tell everybody, okay, now go talk to somebody that you saw. So the conference is next year moving forward. Now it's going to be in May. The end of May. It's going to be at ESF, SUNY ESF again. We're going to have it for 3 days. And the website will be updated soon. It's called stratus-conference.com. You could just go into Google and type Stratus Conference and the webpage will pop up. And we'll be updating that soon. And there's no papers. Typically, we don't have papers. So it's just an abstract about what you want to talk about. It'll be like a 10-minute talk. And a lot of networking. And we have a lot of cool activities like trivia and, of course, the traditional, icebreaker thing, so on and so forth. So everything is just like your regular conferences. And, so look for the call at our website, and it will be in May in Syracuse.
That's great. What we'll probably do is have you back closer to that time to talk, and then also have the opportunity to have you talk about the book that you're working on, radiometry and radiation propagation. Last question, keep it as succinct as you can, only because we're running out of time, which is a great thing for us. You've worked with so many students. Can you give your life advice or, an element of life advice that you give to the students that you touch?
Yeah, I guess sort of, again, trying to keep it super concise, but, about what it is you want to do, right? So for me, clearly, I was in many different directions, I guess, was in science, wasn't sure what I was going to do, was in science and engineering, and then went to music, and then back to science again and everything. And it turns out, it has all worked out, right? And, so we get kids that come into the major and they're working on a particular topic, but I can tell they're really not interested in it. But for one reason or another, they're, I don't know, afraid to step up to the plate to switch gears or something to that, or even coming into the program the other way around from another major, right? That could be the deal. And I just tell them, just do it, right? Just you know, what's the phrase? Jump off the cliff, you'll grow wings on the way down, right? You'll figure it out. So, you know, just find something that you think you are passionate about, because going back to the job career thing, you know, moving forward for the rest of your life, you know, working like we do is a big part of our life, right? I mean, it's probably some majority of our life, right? And we spend the first 20, 25 years figuring out how we're going to spend the rest of our life. So I would just say, you know, for that, your day job, if you will, you know, just really try to don't be afraid to try different things and find out, is this the right fit for me? Nope, jump ship. Right? Is this the right fit for me? Nope, jump ship. And early in life, you can get away with that. And, you know, I don't know, maybe even later in life, you can get away with that too. But I think that's a big piece of advice.
You've been listening to Dr. Emmett Ientilucci, Associate Professor and Graduate Admissions Chair at Chester F. Carlson Center for Imaging Science. I'd like to thank all of you for joining us. I'd also like to thank the Institute of Optics, Genius New York, Luminate Accelerator, AFWorks, Sidor Technologies, Archangel Imaging, and AUVSI. Special mention to our producer, Scott Fitzgerald at RockVox Studio in the heart of optics, Rochester, New York. By all means, I hope you like this program and subscribe to us. Find us on Twitter and LinkedIn and Threads. We are joining that community. We're very interested in how immersive technology positively impacts safety and human connection. And if you have a story we should feature or a guest that you think would further this conversation, please let me know. You can reach me at Jennifer@circleoptics.com. Thank you for joining us.
Thank you.